Hi everyone, welcome to lesson 5. In this lesson, we're going to first create a box plot using ggplot to compare the body mass of the 3 penguin species. Then we're going to run an ANOVA using both the AOV function as well as the LM or linear model function. And the reason we can do that is because an ANOVA is a linear model in which the explanatory variable is categorical and there are 3 or more categories. And then we're going to aggregate data so that way we can see our data frame, which is here, and have it so we just see the mean for bill length, bill depth, flipper length, and body mass for the 3 penguin species. Okay, so let's create a box plot comparing the body mass of the 3 penguin species. So in the penguin's data frame, we want the explanatory variable to be species and the response variable to be body mass, and we're filling the boxes based on species. So let's run this, and what we see is that Adeli and Chinstap are very similar, but Adeli and Gentoo are very different, and then Chinstap and Gentoo are different. So the first thing we're going to do is look at the means for the 3 species and assign them as different objects. So let's run this, and now we see them right here. Alright, next let's use the AOV function and the LM function to do an ANOVA. What we want to do is see the summary of the AOV function, and what we want is the response variable, so body mass, squiggle the explanatory variable, so species, and the data frame penguins. And what that gives us isn't a whole lot of information, but it does give us a p-value. And now let's do this for a linear model and see what happens. So it gives us a bit more information. It gives us the minimum, first quantile, median, third quantile, and maximum. It also gives us a p-value. And the way we read the coefficients is similar to how we do in a t-test. So the first one is what species is first in the alphabet, so that'd be Adeli, and the mean is 3,766, and that makes sense because in our environment here it's 3,700.66. Then Chinstap is if we add 32.43 to 3,700.66, and if we do that, we get 3,733.1. And then lastly, Gentoo is if we add 1,375.35, not to Chinstap, but to the intercept, to Adeli, so 3,700.66. And if we add those two numbers together, we would get the mean, which is 5,076.02. And lastly, let's aggregate data, because this data frame is like kind of overwhelming to look at. So let's make it a little bit easier. Okay, so we're going to create a new data frame called penguins_aggregate. We're using the aggregate function on the dataset penguins, and we only want columns 3 to 6. And columns are after the comma, rows are before the comma in square brackets. So we want to leave our rows alone. And then we are looking at columns 3 to 6, which are bill length, bill depth, flipper length, and body mass. And then the way we are aggregating is by species in the penguins data frame, and what we want is the mean. So let's run that, and we basically summarize this very big data frame into something that's a bit easier to look at. And if we look at the mean for body mass, it matches the values here. Okay, let's do a quick recap. The first thing we did was create a box plot plotting body mass against species using the ggplot function. Then we compared the means of the 3 penguin species for body mass using the AOV function and the LM or linear model function. Then we aggregated the data to view the mean for columns 3 to 6 for each of the 3 penguin species using the aggregate function. Alright, I hope you learned something today. Happy coding!